We'll take a few minutes now and discuss WebTools for GemStone Smalltalk. GemStone 64-bit includes a new goodie called WebTools, which you can use to interact with a running GemStone system through a web browser. Browse code, version information, statistics, stat monitor, some other things, and it's extensible. This is some information on me. So our agenda, we're going to look at first some other tools, what motivated this, then a demo, discuss the design, how we would add a new tool, some things that I've learned doing some JavaScript work to do this, and then what is available, where this may go in the future. Other tools. First, some of you may be familiar with Topaz. Topaz is a command line application that's available in Unix and Windows. So I can launch Topaz, log in, run 2 + 3%, and that gives me 5. So this is kind of your command line access to GemStone. And it's the native way that the core GemStone developers who are building the product itself will do much of their work. And it's used internally to create our distribution. It's used internally for testing and debugging. It's recommended for batch and maintenance jobs. So if you're doing backups, mark for collect, things like this, this would be the typical tool that you would use. And if you can use it for reproducing bug reports, that is very nice because it is a way of confirming it using a script. It's analogous to shell or for example, bash, where you can enter commands and get a response. Run, do it, print it. It's scriptable so that you can file in and create scripts that it files in and runs. But while it's may be comfortable for those who have a background in VI or Emacs or Unix, it's not as comfortable for the typical Smalltalk programmer. Another tool that's provided that's used by system administrators, something called Stat Monitor. Stat Monitor is an executable that captures statistics about a running GemStone system. And then there's a product called VSD, Visual Statistics Display, that can be used to look at and graph information about a running system. So for example, I can take a look at the number of free frames in the shared page cache for this running system. So this is tool that's used extensively for performance analysis. If you're a GemStone customer, we strongly recommend that all production systems should have Stat Monitor running. It allows us to analyze the system if there's a crash. If you call support and say, I'm having trouble, the first question we ask is, do you have Stat Monitor data? If so, then we can analyze it. If not, then start up Stat Monitor and let us know the next time you have a problem. But this is a TCL-based application, uses third-party libraries, has various limitations, doesn't behave well on Windows 7. There's some file size limits and other challenges. We'd like to be able to reduce our dependence on VSD. One of the traditional tools is Gem Builder. GemBuilder provides GUI-based tools. It's an add-on for client libraries, a client library add-on for desktop Smalltalks. So VA Smalltalk, we have a library that files in, and you can access tools to get to GemStone through VA. Syncom Smalltalk is available as well. It has a rich set of tools. This is where most GemStone developers have traditionally done most of their work. GemTools has been out for a few years now. This is what's typically used by the Glass or Seaside customers. This is a Pharo-based application that includes code browsers, debuggers, Monticello, Metacello, so on. There are some limitations with it. It does require specific server-side code, so it can't be used with just any GemStone installation. It requires specific code to be loaded. And it uses OmniBrowser as part of its graphical user interface, which makes it very network dependent, so high amount of network activity. Makes it essentially impractical for use on a remote server. Jade is another unofficial product that is available for download. With this, you can log into a GemStone system and have a transcript where you can execute Smalltalk code, inspect various values, and interact with a code browser and debugger, inspectors, and so on. So this is a useful tool, but works only under Microsoft Windows, and again is yet another application that needs to be downloaded, installed, run. So more complexity. Also coming up, you'll see tomorrow, Toad. Dale has that, and that provides some web-based tools. So what's motivating our exploration of these web tools? Well, one is we'd like to have a graphical user interface. Lightweight, simple to install and use. Minimal network and CPU usage. Cross-platform, so that instead of just running under Windows or requiring some other things, it cross-platform, minimal use. Extensible, where users can add new features to it in a relatively easy way. And then experimenting. It's nice to be able to experiment with new technology. So let's take a look at WebTools. We're going to open a web browser on my local machine where I've got it running. So I have Topaz running here, and I'm running WebTools. And if I bring up Chrome, give it a generous window, I'm here on my local machine, port 8080. First, we have a list of available tools. And some of these are just examples, experiments. I have a version report that just tells us information about the GemStone system that's currently running. What the process ID is for the stone. The process ID for the gem that's running WebTools. The version number, the build number, operating system, and various other pieces of information. So that would be version report. Current sessions, I can look at a list of who is logged in to GemStone currently. So data curator, a couple of garbage collection sessions, symbol user, and another data curator. Information about each of these logged in sessions. PID, host, how old is the view? And if you hover over the label, the heading, time since the session's most recent begin, abort, commit. Are we in a transaction, out of a transaction? Are we holding on to the oldest commit record? What's the serial number? What's the session number? How long has it been since this session last made a request to the stone? How long since it logged in? So most of my sessions logged in 6 hours ago, one did 20 minutes ago. How many commit records have occurred since this session got its latest view? And then some other information. If you click on one of these, it will then bring up cache statistics. So if you've used any of the cache statistics, there's a great deal of information that we provide on running processes. Again, helpful for doing analysis, tuning. What is the abort count? We can see the number of aborts done by a gem. So far this logged in session has done 4 aborts. How many classes? What's the PID? There's just a number of pieces of information that can be very useful to analyze and understand. That's for the gems. We can also go look at the stone processes. So there's the shared page cache monitor, the stone process, free frame server, AIO page server, page manager. So if we go look at the shared page cache, it can give us various pieces of information, including the number of frames that are available in this shared page cache, the free frame count, and various other things. So we have 31,000 frames total, of which 28,000 are free. So that tells us something about our running system. Likewise, we could go look at information about the stone. And something that we look at periodically is total commits. So how many commits have there been since the stone was started? So 68 commits, 19,000 aborts. So various pieces of information. So you can look at information about a currently running system. More familiar, maybe a code browser. Here we have a multi-pane code browser that shows us information. We have a list of packages that are installed in this particular system. And those are also gathered together in dictionaries. So the globals is the main system list of classes, of which, for example, we have a number of stream classes. And Norm mentioned the new foreign function interface that is part of things. You can group things. So in the announcements category, we can select one of those. If you edit here and save, we now have a new class that's defined. If you have a typo and try to save, it will give you information showing you that you have made an error, where the error is, and as you correct it, it will remove the comments. We can, of course, then just say, well, I don't need that class, that one, so we're going to go ahead and remove that. Let's see, maybe an example here. The announcer class has various method categories. It also has some variables. So subscriptions is an instance variable. So we can see a list of the methods that reference the subscription instance variable. We can also look at the class side. This doesn't seem to have any methods. The announcement class has various methods. We can look at comma method, see how it's implemented. We can look and see what are the superclasses up through the superclass chain for this class. And that takes us up through that. We can look at implementers. of as announcement. So there's a series of implementers on the class instance and various methods there that we can see and look at. One of the things that you might notice here is that different highlighting, in addition to highlighting, we also have this green underline. That helps identify step points. So if you want to set breakpoints, see where you are in the code, step point information is useful in that regard. We can, of course, attempt to edit code, and again, if we have errors and save it, it will say, well, we were expecting a right parenthesis there, and so we'll go ahead and put that in, and so we can save the method, go back, and see that our change was saved. So that is some information about that. Let's see, I do want to say, for example, on array, sequenceable collection. So if we look at the at method, for example, it's implemented in array as a primitive, but we can also go and see how it's implemented in object. So work our way up the implementation. So we have a list of implementation and inheritance. So that gives us kind of a basic overview of the code browser. I'm going to come back to statistics. Workspace, 2 plus 3, display it, gives us 5. If we have, again, I think 2 plus, display it, it should expect a primary expression. So we'll 2 plus 3 gives us 5. So that we can also come up with, there was a halt, do you wish to debug it? So we'll say yes. We now have a view into the execution stack and see this is our, the code that we're actually executing, where the halt is highlighted. The receiver of the halt is the integer 2. And so this gives us a view into debugging. One of the things that you may notice here at the bottom is we're capturing some numbers, some information. Since I've opened this window or started, I've had 58 round trips to the server. This last request took 2 milliseconds on the server, 9 milliseconds on the network, and 14 milliseconds on the client. So one of the questions that we have often just in dealing with why are things slow, where is it happening, where is the problem. So this is just some information I wanted to capture so I would know where the bottlenecks are. And if I could connect to a server that was a long ways away, you'd see that the network traffic is the primary overhead on many of these things. Visibility into the object log. So if we had a halt, we can actually debug the continuation that was the halt. So we can go and look at things. Other than that, we've got a history of the various things that were loaded and when they were installed and where. Is there a stack available for debugging? So we can get more information if we don't see all the information in the display. So that's the object log. Shared page cache, for example, right now while I'm running, there's 9% of the shared page cache has data pages, clean, 91% of it's free. So this is kind of a visual peek into the current shared page cache to give you an idea of how full your system is and what is currently being used. So other pages, commit records, bitmaps, and object table. So that brings us to statistics. I have loaded one statmon file, and this statmon file is from x86 Linux machine. This one happens to be 231, is the version of the system that was running for this Seaside application. We have information about a variety of processes. This statmon file was captured, this is US format, October 19, and we have information about the shared page cache. One thing we can do is we can go look at the page cache types. So this is going to give us a graph over time of how the shared page cache was used. So most of it's data pages, but you can see that there's also object table pages, and what the ratio is, how much is used of different parts of it. We can also take, for the shared page cache, and go look, for example, at free frame count and maybe the frame count, and generate a new graph that shows both of these. And so the frames available is 46,000, and the frames free is between 7,000 and 10,000. So this is a fairly heavily used system where occasionally we drop down to 6,000 frames free, but most of the time we're using it pretty well at 7,000 frames free. So most of our 46,000 frames are in use. Because we're in Smalltalk and we can analyze the information, we can look at the data and say, who is holding the oldest commit record? Which gem is holding the oldest commit record? So what was the maximum commit record backlog when this gem was holding the oldest? So in this case, the maximum commit record backlog is 14. So that's evidence of a very healthy system. That's not a problem that needs serious attention. We can look at other information. Since I know that this is a Seaside system, one of the statistics we capture with Seaside is each time we serve a page, we increment a counter. And so I could go graph this and say, well, when we started taking statistics, we had served 28,000, and by 10 p.m. we had served 3,500, excuse me. And you can see that the system is largely quiet overnight, and then starting at about 10 a.m. the next morning, we start climbing again for serving Seaside pages. Another statistic that we can capture with Seaside is how long it took to serve each page, how many milliseconds we spent building the page that we're serving. And so that, again, is going to be a cumulative number of milliseconds. But perhaps more interesting is some statistics that say, well, how many pages per second have we been serving? And so here we have, you know, half a page per second, so about one page every 2 seconds. but that's graphed on the left. On the right, we see the time. And so the blue line shows us that it took about 1.5 seconds to generate, or 1,500 milliseconds to generate a page at this particular point. So most of the time we're down in the vicinity of 500, 300. Quite a bit of the time we're down 47 milliseconds, 68 milliseconds. So this gives us a nice view of how long did it take to generate the pages. So these are some pictures into the system of statistics for a variety of processes. We can also look at the Unix system itself, see how much memory it had, what the load average is over time as the system is running. So generally a nice low load average. So that's some information about statistics and a little bit of a demo of what tools are available. So let's discuss a few minutes of just the design of this. We have all the code in GemStone. There is a web server that's one class and a dozen methods, a couple dozen methods. So very, very lightweight. We're not incorporating any of the other web servers. This one is just very custom for this particular use, not a generalized server. The place that we interact with, we serve files out of a www directory in the GemStone product tree. So here are the various files, scripts, CSS, and other things that we have. So that would be the location of the files in the GemStone examples directory. GemStone is not serving up web pages. GemStone, or in C-side sense, it is not generating the web pages. It is instead returning JSON for recognized methods. So there is a request that's made. GemStone will then generate JSON to return, and the web browser through JavaScript will parse the JSON and build the page. Each tool, and so we can think of each of these as being 6 or 7 tools. Each tool is represented on the server by a specific class. And there's class-side methods, some optional, some required class-side methods, some optional, and then instance-side methods, just JSON to return some data. So we serve files from the file system. By convention, we put the HTML files in the root. We put JavaScript in the scripts directory, style in the CSS, and more complex frameworks can have their own directory because there may be lots of files in them. Each tool identifies an HTML file that it uses, and the HTML tool is obtained using an AJAX call and then adding it to the existing document. So we can use JavaScript to add behavior and CSS to have style. And generally we've split them out, but in some cases we do put them all together, and we'll have an example of that. So one common question is, why aren't you using C-side for this? And part of the answer is we're wanting to have as light a weight solution as possible. Although this is being developed in GemStone 3, version 3x, it is something that can run. It would be easy to port it back to earlier versions. And I have visited some existing customers and users who have ported this back to earlier versions so that they can run it in their environment. It should be able to run in 32-bit as well. And this is something Seaside requires 64-bit 2 dot later. We wanted to make some fairly heavy use of JavaScript, and having all of that come through HTML seemed like a bit of overhead. And so the primary addition to GemStone base is adding a print JSON on method to a variety of classes, so that we can now send as JSON to various objects, and then they will create strings that then are passed on to the web server. But why not Seaside? That's a fair question. Wanted to explore some other things, and although we're passionate advocates of Seaside, occasionally try out some other things just so we can say, yep, we've tried those other things and Seaside still has some advantages. It was interesting, Avi Bryant earlier this year had a keynote speech at Smalltalk Solutions, and his talk was on web architecture. And he said that the old style web architecture is to do a get and post, returning heavy, large HTML files. Seaside offers distinct advantages, that it can save state on the server, but the newer approach to web applications is async background requests for JSON from a server with stateless interaction, reducing the need for saving state on the server. So although Seaside is ahead of the competition for most of the for any other web framework out there, it still might not be the last approach we ever have to writing applications. We may explore some other approaches as well. And the next generation web framework, no components, no continuation, no canvas, just JSON builder using callbacks, for example. So this is Avi's comments on where the future of web application development, where he sees that going. So what would it be involved in adding a new tool to our web tools? So we're going to add a configuration report. So one of the things that we have in GemStone is system stone configuration report. And if you inspect a stone configuration report, you will get a dictionary with a series of keys and values that tell you various configuration aspects of the system. Well, that might be something nice to show in WebTools. So what we will do is we will copy and edit the version report. So there's a version report. You may recall the version report shows us attributes and data. So we'll go in and copy version report and make it a configuration report. And from the version report, we will copy one method here and 3 methods there. And the description will be this information about the stone configuration. The display name will be configuration report. And we'll put it at the end of our list. And for its JSON, what it will return is the stone configuration report as its data. So this is the extent of the Smalltalk code needed to support what we're going to display. So we will save that, and that commit failed. So we may have done some other things. So I'm going to need to abort and do that over. So that will be a configuration report. And in that, we will put Stone configuration report. Commit just to make sure we're not going to get a conflict. Come back, copy across our 3 class-side methods. Stone configuration. Configuration report. And we'll put that at the end. So we successfully commit, and if we refresh, we now have a configuration report as one of the options in our list of tools. Now, we don't have any HTML for this, so if we ask for it, we'll send the request. We're actually sending the request in the background, and so we need to bring up our JavaScript console to see that we got a 404 from the server, not found. So the next step in that is to copy version report.html and make some edits to it. So we have version report.html. I'm going to make a copy of that and rename it configuration report. And then go ahead and open it with a text editor and take a look at the code, see what it's involved. So one of the things is we have a script and we've got a div. So what will be involved in this? Well, the script has a tab panel, a table. We're going to add a new tab called configuration. And it's going to show the Stone configuration. And when it gets added, it's going to have a configuration table. And it will interact with the class on the server called configuration report. And when it gets some data, it will put the data that it gets. And it's actually going to be getting not 2 pieces of data, but just 1. So, and it will, so we only need to put 1 piece in. The field will be GemStone. I'm sorry, it will be the stone information. So for each piece of that, we'll have a key and a value, and the field will be the value. And I'm sorry. We'll take a look at that in a moment. And then the actual HTML is going to be a configuration panel. And configuration panel. Configuration report. And it's going to have a table that displays the information. So we can save that. And one thing I'm curious about is what data do we get from the server? So I'm going to say console.log JSON. So this will give us a chance to look at the data and see what's coming back from the server. So going back to our web browser and saying, can we display it? Okay, we now have a page with attributes and so on, but we had an error because we weren't able to read some properties and so on. And so what information did we get back? Well, we got back stone that is an object with keys and values. So we will go edit our code a little bit to say, well, what we're getting is for the stone, we're going to iterate over the keys and values, and we will display the keys and the values for each of them. So let's see if that works a bit better. Okay, so here we have a configuration report that is giving us information about the debug level, the number of shared counters, the CR backlog threshold, target %dirty, where the key file is, and so on. So here is an example of adding a new tool. So to add a new tool, there's relatively simple code on the server of just, here's the information that I want to display. And then a matter of, and here's where you need to have some expertise in HTML, JavaScript, CSS, and you can display the information that you want there. So that gives us an example of adding a new tool to WebTools. So some things we've learned by doing this. Of course, if we're working with HTML, JavaScript, and CSS, then we're editing in a text file rather than in an image. So that's a different experience for Smalltalker. Assignment versus comparison. JavaScript uses single equal for assignment, and double equal is the equivalence comparison, and triple equals is the equal or identical comparison. So a certain amount of changes there. Closures. JavaScript does have the ability to iterate, but we heard a little bit yesterday about how much does your language get in the way of what you're trying to say. And I do find that the Smalltalk idiom for iterating is nice. The fact that just square brackets is a way of saying this is a function, as opposed to having or a closure, as opposed to having define a function and provide the arguments in that way. One of the things that trips up programmers coming to JavaScript is that curly braces do not provide scope. So you can have variables inside that are visible outside. So curly braces don't limit the scope. Everything defined, all variables defined inside a function will be visible inside the function. Of course, we have our 59 reserved words that can't be used for temporary variables. And one of the things that I find interesting is JavaScript is not tiny. And if we look at, I have Chrome running with one tab open. And there's 5 processes running that are taking up 80, 60, 50, 25, and 20 megabytes each. So a number of processes running, taking up a fair amount of space. So when people say that Smalltalk is large, don't let them give you that. So what is the future for this? We currently have a code browser, class hierarchy. In the current tools, some things I'd like to be able to add to the current tools. In the code browser, I'd like to be able to deal with breakpoints, class hierarchy, more context menus. Statistics is the area that I think will be the primary focus, because this allows us to do a fair bit more sophistication and analysis. Zoom, We do now have multiple graphs per chart, so I could update this. Doing some analysis, have the system know what it's looking for. We have a debugger where we can look at a stack, but I don't yet have step or edit and continue. New tools, Inspector, Monticello, Metacello, these things would be nice to have. And of course, this is not officially supported, and you didn't see it on Norm's promised list of features for the next version. So while it's currently there and shipping in the product, it may be that this is what it stays at, depending on resources and needs. Feedback, of course, is welcome, and the code is out there. And as I say, I know of places that are building their own dashboards. Just as we looked at monitoring some system statistics, you could set up something that would just monitor your own internal statistics. So how many tasks do I need to run? How many jobs are pending of my own internal process? So you could build your own dashboard here that you could monitor things. So that is WebTools, and invite any questions or comments. Otherwise, we can take an early break. Okay, thank you very much.